Hi guys, it's Mrs. Almond and I'm going to walk through with you area of composite shapes. So the first question that we have is same and different. So we have A, B, C, and D. We have a square with sides that are 3 inches for A. For B, we have a rectangle with sides 12 inches and 2 inches. For C, we have a right triangle with legs that are 6 inches and 8 inches. And then D, we have a square with sides that are 5 inches. Go ahead and take a moment to answer in your Ed puzzle. Which or what do you think is same and what do you think is different about this problem? All right, let's take a look at this actual problem that we're going to solve today. Making sense of the problem. So Tyler's family builds a new pen on their dairy goat farm. The diagram represents the new pen. Each goat needs at least 50 feet squared of space. What is the greatest number of goats the new pen can hold? So first, I'm just going to start with I need to know each goat needs that 50 feet squared, and I want to know the greatest number of goats. So I am looking for area because it's feet squared. So if you take a look at the goat pen that we have, you'll notice that it's not a normal shape. So we have some shapes that are all put together with this. We have two options of how we can solve it. We can split it into smaller shapes, or we can just make one large rectangle and subtract out the missing portions. I'm going to go with that of making one large rectangle. So that portion is going to be blue. And then I'm also going to have this portion that is green. So I'm going to start with just simply finding what is the area of the whole entire thing. So I have 40 by 12 plus 36 for that side. So 12 plus 36 is 48. So I have a 48 by 40 feet rectangle, which ends up giving me 1,920 feet squared. That would be my total if that was my whole entire pen. However, I need to subtract out the triangle and that rectangle that I made. So let's start with the triangle. So my triangle is going to be 12 feet. Just going to make a triangle there to remind me what I'm doing. 12 feet by, I need to find this portion right here. Well, if I know that whole portion is 40, so it's 40 minus 22 is going to give me my x. 40 minus 22 is 18. So I'm going to do times 18, and to find area of a triangle, you're doing base times height times a half. So 12 times 18 times a half gives me 108 feet squared for my triangle portion. Next thing that I have to find is that green that I shaded, which is going to be my rectangle, which I have as 6 by y. I don't know what that is. Well, I know this total distance is 48. So I'm going to do 12 plus y plus 21. 48 equals my 12 plus 21, which is 33 plus y. I end up being y equals 15. So I'm just incorporating some equations in there. So it's a 6 by 15 rectangle. 6 times 15 is 90 feet squared. And now I can solve. So I'm going to take my total area and I'm going to subtract it from each of those portions that I found because I only want to know what the pen is. So if I do 1,920 minus 108 minus 90, I get 1,722 feet squared. So that's my total for my pen. However, each goat needs 50 feet squared of space, and I need to know how many goats do I have. So I need to answer still the last part of this question. So I have to divide by my 50 feet squared, and that gives me 34.44 goats. Well, hopefully you should be screaming at me, Mrs. Almond. You can't have a fraction or a decimal of a goat, so we need to round. And since we can't round up because we don't have a full portion of a goat, we need to keep it at 34 goats is how many goats that they can have on their dairy farm. Take a look at what else you could have done. So if you look at this example, sample B is exactly what I did with finding your total area and then subtracting out those two portions. You could also do sample A, which is splitting it into a triangle, a rectangle here, another rectangle, and another rectangle portion here, and then finding that total area here. So you can split it into smaller shapes, or you can find the total like I did and then subtract out those missing pieces. Two options as you're solving. So let's just look at some questions with this. And we have a rectangle and another rectangle. Sometimes you'll have a side that's unknown is what this is saying here. So for example, we have our unknown side of BC, we have X. So we know side BC equals x. We also want to know how in the world does DE represent 24 minus x? Well, here's how that works. If this whole total distance is 24, we have 24 minus our unknown of BC to give me x. So that is how I end up with my side length 24 minus x. So it's a one way, which is kind of what I was doing in the last example of how you can use variables to find those unknowns. We also have, write an expression for EF. Well, EF is right here. If this whole side is y, and we know this portion is 12, we can take y minus 12. So that's what we would have for the side length of EF. So again, we're just using our variables to work and find those missing pieces. Here, we want to know, explain how the expression 12x, which is our portion right here, 12x, it's all my green, plus 24, which is right here. And then we know this is y minus 12 from my previous explanation. So how is that representing the area? Well, you're just taking those two pieces, which I shaded in green and blue, and you multiply those together. So 12 times x to get that space, and then 24 times y minus 12, which is just your side lengths, and then you add them together to get your total area. Then it also wants to know, explain how 24 minus 24y, so that would be if I had 24 times y, so that's your whole entire figure, and then you have to subtract now this portion right here, which is 12, which is my side right here, times, if you'll remember, this one was 24 minus x, so that gives me my dimensions for my green rectangle. So you just had to subtract it out, which is very similar to what I did as the example. So again, it's still working those same ways, but we're just now incorporating our variables in here. So here's another problem. We have, the diagram shows the plan for a lawn. A landscaper needs to buy grass seed to cover the lawn. One bag of grass seed covers an area of 900 yards squared. How many bags of seed does the landscaper need to buy to cover the lawn? So let's just take a look. I just want to circle this to remind me, okay, that's how much each bag covers. First thing I am going to go with is finding the area of my whole entire rectangle. So I have 90, and then I have 18 plus 10, which is 28. So my whole rectangle is going to be 28 times 90, which is 2,520 yards squared. Then I need to take out my patio. Well, looking at my patio, I have a trapezoid, but you could also see that you can split your trapezoid here and make two triangles. I know that's not the straightest line, but it works there. So I have my triangle, which is 10 tall, but then it is also 54 long. So I have that triangle. I probably should have used a different color. 54 long and that 10 tall here. All right, for my triangle. So I'm going to do 54 times 10 times a half. And then I also have my 62. Let me use another color. Not a good color choice. 1 second. Sorry, guys. I also have 62 here for this distance, showing that triangle. So 62, and I got that from doing my 90 minus my 14 minus my 14. So I am going to have my second triangle, which is going to be 62 times, again, my height of 10 times a half. I guess I just realized I didn't find my other total, and I can just add these two together to give me a grand total of 500 yards squared for my patio. I want to know how much grass seed I need, so I'm really going to subtract my total from my large 2,520 that I found with my huge rectangle up there, minus my patio 580, and that leaves me with 1,940 yards squared. And I know that each bag can cover 900 yards, so I can just divide by 900. So 1,940 divided by 900 gives me 2.15 bags. So I need a little bit over 2 bags, so I need 3 bags total. All right, we have another figure right here. What is the area of the figure to the right? So I could actually split this. I'm going to split this into smaller figures. So I can split it here, and I can find my total area. So I have a 3 by 4, which is 12. And then I also have a 2 by 2 triangle, which ends up giving me 2. So I can add 12 plus 2, which gives me 14 centimeters squared as my total area for that one. And then my last question, what is the area of the shaded space? So there's a lot going on here. There are some options that you can split it into the smaller pieces, or you can make one large rectangle. So let's just go ahead and go with that. So I have my yellow area, and then let me change my color, and I have a triangle. So let's start with my total, my large rectangle, which is 15 by, I have a 10, and I have 4 feet here. So that would be 15 times 14 would give me my total, which is 210 feet squared. Then I can go ahead and do my yellow portion, which is going to be 3 by 4, which is 12 feet squared. And then I have my triangle up here, which is 2 by, well, I have to figure out what that would be. This is 3, so 3 plus 10 gives me 13, but my total is 15, so this is going to be 2. So I have a 2 by 2 by a half, which is 2 feet squared. And then don't forget this hidden portion inside, which is 8 by 4. I just covered that up. So I have an 8 by 4, which is 32 feet. So now I need to find my grand total of just the shaded space. So that would be 210 minus 12, which is right here, minus 2, which is right here, and then minus 32, which is this portion right here, that rectangle, which leaves me with 164 feet squared. That is it.